The GATE Physics 2017 problem reads as follows. Consider an ideal operational amplifier as shown in the figure below with R1 equal to 5 kilo ohms, R2 equal to 1 kilo ohms and RL equal to 100 kilo ohms. For an applied input voltage V equal to 10 millivolts, the current passing through R2 is. Since this is a numerical answer type questions, we are required to find our answer and round it off to 2 decimal places. And the unit should be in microamps. Before solving this problem, there are certain things we'll investigate. First, is this an ideal op amp? The answer is yes. How? Because it's given in the question itself. It's an ideal operational amplifier. Yes. If the question is silent about it, just take it to be an ideal operational amplifier. But here we were given, so we are good. Second, check if there is a feedback or not. How do we check is there a feedback or not? If the output node, Vout, if this signal is being fed somewhere to the input. So we see that this output through this resistor, feedback resistor R1 is being fed to the inverting terminal V minus. So yes, there is a feedback. What kind of feedback? A negative feedback. Now, one more thing, since this is an ideal op amp, we'll assume that the current flowing into inverting as well as non-inverting terminals is 0 naturally. And the final thing, we'll assume that there is a virtual short. So this is a unique property of an ideal operational amplifier, that the positive and the negative input nodes are virtual shorts. This means they are at the same potential. So what this means is that I'll redraw the circuit here. So this is 0, the input currents to both, this is 0. So why it's happening is that, let's assume that resistor Rin is here, right? So let's try to find this Ohm's law across this resistor. So I'll write V plus minus V minus equal to I times Rin. So this quantity is 0, sorry, I times Rin is 0. So we get V plus equal to V minus, which is what we refer to as virtual short. Rin is the input impedance, which in this case usually it's very large value. So that's why it's called a virtual short. And what effectively means is that we denote it like this, a dotted line connecting between inverting and non-inverting terminals. So with the non-inverting terminal we were given a voltage V. So this implies, let's assume the voltage at the inverting terminal is Vx. So what we'll get is Vx equal to V due to virtual short. Now, so this node is also Vx because this is simply a wire. This is Vx, this is also Vx. Now let's write Ohm's law across resistor R2. Ohm's law across R2. So we'll write Vx minus 0, that is the potential drop across R2 resistor, is equal to the current through resistor I2, we assume to be I2, times the value of resistor R2. So we'll get Vx equal to I2 R2. I2 will get Vx upon R2. The value of Vx is nothing but V upon R2. The value of V is given in the problem as 10 millivolts over R2 is 1 kilo ohms. So we'll get 10 microamps. So the value of current that we have obtained is 10 microamps. We'll simply put this value here and we are rounding off to 2 decimal places. So we can write that our answer is 10.00. That's all. Thank you for listening.